Hello students, welcome to ePhysics. Students, in this video we will start from the part from where we left in the previous video. In the previous video students, we have studied about motion and also about rest. Okay, and along with that we studied about distance and we studied about displacement as well. In that video, we have differentiated between distance and displacement, and here we will discuss few questions related to these distance and displacement. Okay, so let's start it. Now, the first question is on the screen, students. An object has moved through a distance. Okay, through a distance. Can it have zero displacement? The first part of the question is, can it have zero displacement? Students, in the previous video, we have studied the difference between distance and displacement. Students, distance means the total length of the path traveled by any object is known as distance, and the shortest distance between the initial and the final position is known as displacement. Students, here we have been asked if an object travels any certain distance. Let us consider from A, it moved to B, and then again moved to C, then moved to D, and then again moved to point A. Here, the distance traveled will be AB. The distance traveled will be equal to AB plus BC plus CD plus DA. But here, students, the displacement will be equal to, according to the definition, we know the shortest distance between the initial and the final position. The object started from A, that is the initial position, and the object comes to rest at point A, that it became the final position as well. So, the distance between the initial point and the final point is equals to 0. Therefore, the displacement is equals to 0 over here. So, if yes, support your answer with an example. You can give the example if the object starts from, let us consider, displacement can be 0 only when if the object starts from any point and comes to rest at the same point, at the same starting point, okay, same starting point, then the displacement will be equal to 0. Okay, is it clear? So let's move to the next question. Now, here is the next question, students, on the screen. A farmer moves along the boundary of a square field of side 10 meters in 40 seconds. Students, let us consider this is the square field. Okay, this is a square field of 10 meter each. Now, the farmer moves along the boundary of the square field. Boundary means it travels along the perimeter of this square. So, and it traveled in 40 seconds. So, distance traveled will be equal to 4 multiplied by side. That is the perimeter of the square, students. We already know it. That is 4 multiplied by 10 meters, which is equals to 40 meters. And the farmer took 40 seconds to travel this 40 meter. Therefore, the speed of the farmer is equals to distance upon time taken, that is 40 divided by 40 meter per second, which is equals to 1 meter per second. This is the speed of the farmer while traveling along the boundary of the square. Now, the question is, what will be the magnitude of the displacement of the farmer at the end of 2 minutes 20 seconds? Now, the total time, that is the total time traveled by the farmer is equals to 2 minutes 20 seconds. we need to convert it into seconds. That is 120 plus 20 seconds, which is equals to 140 seconds. Therefore, the farmer traveled for 140 seconds. So how many time or how many revolutions did the farmer complete? So for one complete revolution, or from starting point coming in to this starting point, after traveling the boundary once, it took 40 seconds. So total number of revolution it took is equals to number of revolution it took, that is it traveled for 140 seconds, and for one revolution it took 40 seconds, so which is somewhere equal to 3.5 revolution. It means the farmer first started from here 1, and then again 2, then again 3, and then again this part 3.5. So this is where the farmer stopped. That is, let us consider this is A, this is B, this is C, and this is D. The farmer stopped at C, okay, because it traveled half the distance. Also 3.5 revolution, that is it took 3 complete revolutions and 1/2 revolution has been completed, that is from A to C, okay. Now, what is the magnitude of the displacement? Magnitude of the displacement will be equal to AC. And students, we know all the angles of a square forms a 90-degree angle. And we can clearly see a right angle triangle over here. Let me change the color of the pen first. We can see that is ABC is a right angle triangle over here. And from Pythagoras theorem, we can say AC square will be equal to AB square plus BC square. Finally, we can write it as AC is equals to root under AB square, that is the side of the square is 10 meters, that is 10 square, plus again 10 square, BC is also equals to 10, which is equals to root under 100 plus 100, which is equals to, this is in meters of course, this is root under 200 meters, which can be written as 10 root under 2 meters. Okay, so the displacement over here after 2 minutes 20 seconds is equals to 10 root 2 meter. Students, if in the question it is said to put the value of root 2, you can also put the value of root 2 as 1.414. You can take up to 2 decimal places for the convenience of the calculation. So that's it with this question. Let's move to the next question now. Now, the third question is on the screen. Which of the following is true for the displacement? It cannot be 0. Of course not. It can be 0. How it can be 0? If the object starts from its initial point, travels all along and comes to its initial point again, then the displacement is of course 0. Its magnitude is greater than the distance. Impossible. The magnitude of the displacement and distance can only be equal, okay, or it can be less than, okay, I mistakenly wrote over here. Let me erase it. Now, the magnitude of the distance is always greater than or equal to displacement. Greater than or equal to displacement, of course. Okay. Now, when it will be equal? Only when the distance traveled is in a straight line, then straight line and only in the same direction. Let us consider it is starting from A and it moves to point B and it traveled on a straight line in the same direction. Then here in this case, the distance traveled will be equal to the displacement. Clear? We have discussed the similar example in the previous video where we were discussing about distance and displacement. Now, distance and displacement can only be equal when the object travels in a straight line in the same direction. And the magnitude of displacement can never be greater than distance. Okay, it can only be equal to distance or less than distance. Clear? So this is false. And if the its magnitude is greater than the distance traveled, never. Okay, now let's move to the next part. that is uniform and non-uniform motion. Students, here we have a graph of object A and object B. Students, in this table, we can see that object A travels if we make a graph. Okay? If we make a graph. Let us consider this is the time axis, and let us consider this is the distance axis in meter. Okay? Distance traveled in meter. Students, in the first interval, that is at 9:30, the object is at 10 meters. Okay? The object is at 10 meters. That is at 9:30. And in the second instance, it is at 20. Okay? It is at 20 after 15 minutes. That is from here to here, it is 15 minutes. And again after 15 minutes, that is at 10 a.m. That is 15 minutes. At 10 a.m., the object is at 30. The object is at 30. This was the first one. This was the second one. This was the third one. And similarly, after again 15 minutes, that is after 15 minutes, that is 10:15 a.m., the object is at 40 meters. And the object is at 40 meters, somewhere around here. Okay? Now, students, when we connect these dots, we get a straight line. Here, you can clearly see that object A is traveling equal distance in equal interval of time. How? You can see after every 15 minutes, it is increasing its distance. It is traveling 10 meters only. And again 15 minutes, 10 minutes, 10 meters. And after again 15 minutes, it traveled for 10 meters. And again 15 minutes, 10 meter, 15 minutes, 10 meter, 15 minutes, 10 meter. That is, after every 15 minutes, the object is traveling at equal distance, that is 10 meters only. Clear? So this is what we call a uniform motion. What is uniform motion? If an object travels equal distance in equal interval of time, then the motion is said to be uniform motion. We can define it as, if an object travels equal distance in equal interval of time. Equal interval of time, then the object is said to be in uniform motion. Clear? So this is how we define it, uniform motion. Distance traveled is always equal in equal interval of time. So now let's move to the object B. Okay. Now here, students, when we make a graph of object B, this is for object B. Let us consider this is the distance axis and this is the time axis. Clear? Here, in the first point, in the first time, that is at 9:30, it traveled for 12 meters. Okay? That is 12 meters. And after 15 minutes, it was at 19. It was somewhere at 19. Clear? 19. And after 15 minutes, it was somewhere at 23. After 15 minutes, it was somewhere at 23. 15, 19, 23. And after again 15 minutes, it was somewhere at 35. Okay? 35. And again after 15 minutes, that is at 10:30, it was at 37 only. Okay? So the graph, when we see it, it is something like this. Okay? The graph so obtained is not a straight line, it is a curved line. It is a curved line. Why do we get this curved line? This is because the distance traveled by object B in equal interval of time is not equal. That is, after every 15 minutes, it is not traveling by an equal amount of distance. That is, in the first interval of time, first 15 minutes, it traveled for 7 meters. In the second 15 minutes, it traveled for only 4 meters. And in the third 15 minutes, it traveled for around 12 meters. And again, after 15 minutes, it traveled for around 2 meters only. That is, the distance so traveled at equal interval of time, that is after every 15 minutes, is not equal. Therefore, this type of motion is known as non-uniform motion. So, students, we can define it as, if the distance traveled by the object in equal interval of time is not equal, then the motion is said to be non-uniform motion. Non-uniform motion. So we have discussed few questions here, and we have discussed uniform and non-uniform motion along with the graph, along with the definition as well. Hope you understood the topics very clearly. Thank you very much for watching the video.